Welcome to Empowered Learning. This video will be about how to simplify expressions that have like terms in them where one or more of those terms will include fractions. So I'm going to start off with a few examples and go kind of slow with them so that we get all of the details that goes along with being able to simplify such expressions. After we do about 2 or 3 of these, then we will speed up the process once we know the basics. So let's start off with this first example here. So we have 2a plus 4/5 a minus 3a. So the first thing that I want to say is that the simplest thing to do to start off is that all these terms are like terms because all of them have an a in common with it, okay? And so the way I like to think about it is that A is for apple. So I have 2 apples plus 4/5 of another apple minus 3 apples, or someone took away 3 apples from me. And what I want to figure out is how many apples do I have left? So just to be clear here, if I had a term, let's say I had a plus and then I had 4a squared, something like that, then this term would not be a like term with the rest of these, because although this has an a in it, it is a squared or a times a. Only terms that have an a in it and just a number next to it, and that number is called the coefficient, just a coefficient times that same variable, that is what a like term is, okay? Another example, if I had, let's say, 2b here, then of course this term would not be a like term with any one of these 3 terms either. So we want to make sure that we understand that and we put like terms together. So to put it another way, apples go with apples. Let's see, oranges go with oranges, pears go with pears. We can kind of think of it that way. If we thought of this as an orange here, and we thought B here as a pear. So apples go with apples, oranges go with oranges, pears go with pears. So we want to make sure that we know that. Now, as we get deeper into this particular video, you're going to see how we're going to mix it up to where our expression will have some terms with one variable in it and some terms with another. But for right now, we're going to stick to just having all the terms be of the same variable. Okay, so the next thing that we need to discuss is an alternative way to be able to write this particular expression. And in particular, I'm talking about this second term here. So notice that 4/5 a is the same thing as saying 4 divided by 5 times a divided by 1. And we know that a is the variable, but that variable just represents a number, and we don't know what that number is yet, okay? So since we don't know what the number is yet, or another way of thinking about it is we want this a to be a placeholder, and whatever I tell you to put in there, that's what we'll put in there, okay? The point that I'm trying to make here is that this 4/5 times a, or 4/5 times a divided by 1, because any number can be written as itself over 1, can also be written this way, okay, as 4 times a over 5. And so that's important for us to know, because since we have a fraction here in this expression, one of the things that we are going to need to do is be able to combine like terms with fractions, and thus that means we have to find a common denominator, okay? So we're going to go into that next once we actually get started with the problem, but I wanted you to make sure that you understand that this second term we could rewrite this way, okay? And so I mention that because I know that some students, when they're first learning this concept, they may think that they can put the a down here, and that's not true, okay? So anytime you have some variable or number here like this, it goes with the numerator. So another example of that, let's say if I had 4/5, and let's say I multiplied this times 2, then I'll have some students that think that this means that this is 4 times 2 divided by 5 times 2, and that's not true here, So I know I've seen that before as well. So this is not true, okay? You can't do that. So anytime you have a number, you just put it over 1, and that tells you when you multiply fractions, you multiply numerator with numerator, denominator with denominator. So when we do that, 4 times 2 is 8, and 5 times 1 is 5. So that's what that would be, okay? So we want to make sure that we have those basic things straight before we begin this problem. So now that we've covered those foundational things, let's go ahead and start this problem. So the first thing that I'm going to do here is I'm going to rearrange this to where I have the 2a minus 3a together here. And then on the end, I'm going to tack on this term with the fraction, okay? So if we look here, we know that 2a minus 3a, or put another way, I have 2 apples and then I have 3 taken away from me. What that's going to end up being is minus 1 apples, okay? Or minus 1a. And another way to think about these two terms here is that since we have both terms that have an a in it, I could factor out that a. And then here we know that 2 minus 3, or 2 take away 3, ends up being a negative 1. And a times a negative 1 is just a negative 1a, or simply just minus a, okay? So we know that that's going to be the case here. And then we'll just say this is 4/5 times a. So the next thing that I'll do is, since we know that negative 1 times a is just a minus a, I'm just going to write it like this for this step. And then here I'm going to write this as 4a divided by 5, okay? And we all know why we can do that now. So at this point, we need to be able to add this term, the first term, to the second term. Unfortunately, we're not able to legally do that because we essentially have 2 terms that have unlike denominators. And why do I say that? Well, here we know that this minus a is the same as minus a divided by 1, okay? Because remember, any number can be written as itself over 1. So if I write it this way, then now I have 2 fractions that I need to add together, and they have unlike denominators. And so to make a like denominator, I have to figure out what is the least common denominator in between these 2 numbers here, okay? Now, fortunately, 5 is a prime number, meaning that it's only divisible by itself in 1. And of course, 1 can pretty much go with anything. So here we know that our LCD in this case is just going to be 5, okay? When we deal with more complex problems, we'll talk about how we actually find out what this LCD, or least common denominator, actually is. So since we have that LCD there, what we can do is form what's called an equivalent fraction, okay? And so we're going to take this minus a over 1, and then we're going to figure out what is that same fraction, but it has a denominator of 5, okay? And there's a couple of different ways to think about how to do this. So the quick and dirty way, as I like to say, is we're going to say what 1 times what gives me 5, okay? So 1 times what will give me 5. Well, we know that 1 times 5 will give us 5, right? So if we know that 1 times 5 will get us 5, then we just say 5 times this gives me what here, okay? And so here that ends up being a minus 5a. So how many times does 1 go into 5? It goes into that 5 times. So 5 times this is what? So that's one way to think about it. Another way to think about this is you could say here, I need to multiply this particular fraction by 1, okay? But I need to make 1 look like something so that I'll get 5 here. Well, since we know that 1 times 5 is 5, then that means here I have to have 5 in the numerator as well in order for me to have 1 here. And why is it that I want 1 here? Well, I want it there because I know that anything times 1 is just itself. And so remember, what we are trying to find is an equivalent fraction, meaning a fraction that looks different, but is the same thing as what we had before, okay? So when I say 1 times 5 is 5 and negative a times 5 is a minus 5a, notice that this is the same exact thing as just negative a divided by 1, because here we know that 5 goes into 5 exactly 1 time, and you see here I'm just left with the minus a, okay? So saying all that to say that in this next step here, what we'll do is we're going to multiply the numerator and denominator by 5. And if we do that, then our equivalent fraction is a minus 5a divided by 5 plus 4a divided by 5. Once we're there, we have like denominators, and anytime you have a fraction that has like denominators, we know that we can just add the numerators together here and just write the denominator there. Same thing with subtraction, okay? So let me separate that first. So if we have a over b minus c over b, then we could just subtract the numerators, write the denominator. So in this case, what we have is a minus 5a plus 4a all over 5. And then from here, if we add negative 5a and 4a, that's just going to be a negative 1a over 5. And of course, negative 1a is just a minus a over 5. And this will be our final answer for this particular expression in trying to simplify, okay? So again, remember that we had these two terms. Of course, we had both the coefficients were integers, so it was easy to combine those. But then after that, we had this term here and this one. And of course, since one of them has a fraction, we have to turn the other one into a fraction, like what you saw here, in order for us to be able to actually add them together, okay? All right, so let's look at the second example that we're going to have. We're going to have several in this video, but we're just going to look at this a few examples here to kind of get our feet wet, and then we'll move a little bit faster. Okay, so for our second example, we have 7/5 x minus 2/3 x. And what we want to do is simplify this term into just this expression into one term, okay? Now for this one, we know that we could rewrite this as 7x divided by 5 minus 2x divided by 3, okay? The issue that we have now is that we have a 5 and we have a 3. And so here, these two denominators are not like denominators. So what we need to find is the least common denominator. And what that really is just the least common multiple, which is the lowest number that both 15 and 3 will divide into evenly, okay? Again, since 5 and 3 are prime numbers, then the LCM in this case will just be 5 times 3, okay? Now, how do we know that? Well, there's a way that we can figure out, no matter how big or how small these numbers are, what our least common multiple is, and thus what our least common denominator will be. And so that method kind of goes like this. For 5 and 3, we can break down what 5 and 3 are in terms of prime factors, okay? Now, if we think about what times what is 5, we would normally say 1 times 5, and for 3, we would say 1 times 3, okay? Since 1 is not considered to be a prime number because it is divisible by every number. We don't include that here, okay? Because we know that anything times 1 is just itself. And so the way that this goes is whenever you have all this stuff listed out, then I'll just put the ones back in there to kind of to make it plain here. So we look at all the different numbers. We have a 1, we have a 3, we have a 5. And we circle the most amount of times we see 1, 3, and 5 together in a group, okay? And we do it by rows. So in this row, we have a 1 by itself and we have a 5 by itself, okay? In this row, we have a 1 and a 3. Since we've already circled a group of 1 ones, then we don't have to circle this one, but we will circle that one. And everything that we circle, we multiply. So if I multiply all that together, I end up getting 15, and that is how we get the least common denominator, okay? Now, how does that help us do what we need to do over here? Well, since we know that our LCM is 15, which is also going to be our least common denominator, what we now can do is take each of these fractions, 7x over 5 and 2x over 5, and we can form an equivalent fraction with 15 as a denominator. So here we ask ourselves for this first one, 5 times what gives me 15? Well, we know that 5 times 3 is 15. So if we're trying to create a fraction here that's going to look like 1, but yet give me 15 in the denominator, then that fraction needs to be 3 over 3. Because since 5 times 3 is 15, I would also have to have 7x times 3 here to get the equivalent fraction for that. And of course, 7x times 3 is just going to be 21x. So this fraction of 7x over 5, its equivalent fraction is 21x divided by 15, okay? If we did the same thing with 2x divided by 5, then here we know that 5 times 3 is 15, so that means 2x times 3 is 6x. So once we do that, then 7x over 5 can now be 21x over 15, and 2x over 3 can be 6x over 15. Now that we have like denominators here, we can combine the numerator just by subtracting them and have a common denominator of 15. And here, again, using the apple terminology here, if I have 21 apples and I take away 6 apples or subtract 6 apples, I'm going to have 15 of those apples left, okay? So my fraction here ends up being 15x over 15. Now, we've simplified this expression that has 2 terms into 1, but notice here that any number divided by itself, other than 0, is just 1. So 15 divided by itself reduces to 1. And so here 1 times x is x. And of course we have 1 in the denominator here. And this just ends up being x at the end of the day. So if we were to take 7/5 times x minus 2/3 x, what that would end up giving us is just x left, okay? And so that is our second example, and hopefully now you're starting to get a little bit more comfortable with being able to simplify these expressions that have fractions in them. Let's look at our third example. So for our third example here, we see we have a term that is not looking like a fraction minus a term that does have 1. We know that since this second term has a fraction in it, we're going to have to form this first term as 1 as well. So what we can do is we can say this is 9z divided by 1, because remember, anything can be rewritten as itself divided by 1, minus 4z divided by 3. And so now the least common denominator in between 1 and 3 is, again, just going to be 3. So this one is rather easy. So what we can do here to form an equivalent fraction for 9z divided by 1 is to say 9z over 1 times what is going to give me 3 over whatever, okay? And so I'm going to write this way. So this is a subtraction sign, and this is going to be a division sign here. So we know that we're going to have 3 in the denominator here because 1 times 3 is 3, because it's got to match what we have here, okay? So if 1 times 3 is going to be 3, then of course we have to have a 3 up here as well. Because remember, and let me switch colors here. This is just me saying I want to take this 9z divided by 1 and multiply it times 1. And of course, anything multiplied times 1 is just itself. We're just trying to find another way to be able to write it, okay? So if we do that, then here we have 9z times 3, which is 27z. And we have 1 times 3 here, which is 3. And then we have 4z over 3. So now we have our two terms where both terms have looks like a fraction and the denominators are the same. So once that's done, then we can just combine the numerators by subtracting them and then just write the common denominator. And of course, 27 zebras minus 4 zebras will give us 23 zebras divided by 3. And so for here, this would be our final answer because both 3 and 23 are what we call prime numbers. They're only divisible by themselves in 1, so we're not going to be able to do any reducing here to simplify it, okay? So you could leave your answer this way, or if it makes you feel happy on the inside, you could write it this way with the z in front, okay? No matter what you do, please do not do this, okay? This is incorrect. The z either has to be on top of the numerator or it has to be on the side, kind of halfway between both the up and down part here, okay? And so this will be your final answer for that particular expression and simplifying. All right, so let's look at our fourth example where we're going to have 3 terms now instead of just 2 that we have to deal with. So for this next example, we have 3 terms that we need to combine together to simplify into one term. And again, since all of these terms have some real number times the same letter, x, then it means all 3 of these terms are like terms. So we know right off the bat that we could rewrite this as x over 2 plus x over 3 plus x over 6. And what we need to do is to find out what is going to be the least common multiple between 2, 3, and 6, okay? So I'm going to act like I don't know that this answer is 6 and show you how we would actually arrive at that result, okay? So here what we do is we take each number and we break it down to what we call its prime factorization, okay? So for 2 and 3, since we know that 2 times 1 is 2 and 3 times 1 is 3, the prime factorization for that is just the number itself, okay? However, for 6, we know that 6 can be written as 2 times 3, okay? We wouldn't write this as 6 times 1 because 1 is not considered to be a prime number, okay? And 6, by definition, is what we call a composite number, which is the exact opposite of what a prime number is, okay? If you remember, a prime number is a number that is divisible only by itself in 1. A composite number is a number that's divisible by other numbers other than itself in 1. Okay. And for 6, we know that 6 divided by 2 is 3, and 6 divided by 3 is 2. So in addition to 1 and 6 being able to divide 6 evenly, we have these other two numbers, 2 and 3, that can also divide 6 evenly, meaning that we don't have a remainder there. Okay. So this is how we break this down. Once we do this, then we take all of the distinct prime factors, which in this case, you're going to have 2's and you're going to have 3's. And we circle the row that has the most amount of 2's, circle the row that has the most amount of 3's. So here we see that for 2's, we have 1 here and we have 1 here. So you could just circle 1. So we'll just circle this one. Okay. For 3's, we have 1 here and we have 1 here. So we'll just circle this one. Everything that we circle, we multiply. And of course, 2 times 3 is 6. So that is what our least common multiple is. And so this is the smallest number that will go into 2 and 3 and 6. Okay. So now that we know that, what we need to do now is rewrite x divided by 2 as some fraction that's going to have 6. And of course, to get 6 in the denominator, we're going to have a 3 here because 2 times 3 is 6. So we're going to have 3 there in the numerator for that as well. We do the same thing here. This is going to be 2 and 2 because remember, 3 times 2 is 6. We got to have that in the denominator. So we got to have the 2 matching up here as well. And then for x divided by 6, since I already have a 6 here, I don't need to do anything with this term. Okay. So now that I have that, I know x times 3 is 3x. 2 times 3 is 6. X times 2 is 2x. 3 times 2 is 6. And then, of course, I just have x divided by 6. Now that all of our denominators are the same, I can combine this into one term. And so here I have 3 apples plus 2 apples plus 1 apple. So 3 apples plus 2 apples gives me 5 apples. 5 apples plus 1 more apple gives me 6 apples. And so that's 6 apples divided by 6. And if you remember here, 6 divided by itself always reduces to 1. 1 times x is x. 1 is left in the denominator. And x divided by 1 is just x. Because anything divided by 1 is just that anything. And so for this problem, x would be the final answer for it. And so now you see how we deal with expressions that have 3 terms where all of them have fractions, and how we use this process here of finding the LCM to be able to figure out what our denominators need to be. All right, so let's move to our next example. Okay, so for our next example here, we see that we have our first 2 terms being fractions, and then our last term here not being 1. But we know that since these first 2 are fractions, we're going to have to force this third term to look like that. So here for now, we're going to say this is 9a over 11 plus 2a over 5 minus a. And I'm just going to put this as a over 1. So the first thing that we need to do is figure out what is going to be the LCM, which in turn is also going to be the LCD, least common multiple, which is also least common denominator in this application, for the numbers 11, 5, and 1. Okay. So again, we list each of these numbers and we figure out what it's going to be its prime factorization. Okay. Now 1 we really don't count that because it's not a prime number. And it turns out that 5 and 11 are essentially prime numbers on their own. So we just circle both of these, and our LCD, or least common denominator here, is just going to be 55, which is what 11 times 5 is. So we know that we're going to have to change our denominator here for each of these 3 terms to be something with a 55, okay? So here, what I want, and I'm going to do this a little differently this time, is that I want all 3 of these denominators here to be 55. My question is, what goes there, okay? So to do that, we know that for 9a equals 11 to equal something with 55, we have to say 11 times what gives me 55? Well, we know that's 5. Well, 5 is in the denominator here. 5 has to be in the numerator as well to form this equivalent fraction. And so here, 9a times 5 gives me 45a. So that is what's going to be in this first term here, okay? And so notice I'm doing the work down here this time versus putting it in the problem, just to kind of give you a different way of looking at it, okay? So for the second term, I need to figure out what's going to be here. And to do that, I'll have 2a over 5. And this has to have something with 55 in it. And we say 5 times what gives me 55? Well, we know that's 11. So since 11's in the denominator, has to go in the numerator here. And 11 times 2a is going to be 22a. So that's what's going to go here. For the last term, we need something with 55 again. And so this one's easy because 1 times what gives us 55? Well, that's just going to be 55. Well, if I have 55 in the numerator, I also have it in the denominator. So here this will be 55a. Once that's done, then I can combine all of the terms in the numerator together. All that over 55. And so here we can say 45 apples plus 22 apples gives us 67 apples minus 55 apples. And then we have 67 apples. We take away 55 apples. And what that's going to give us is 12 apples left. Because 7 minus 5 is 2. 6 minus 5 is 1. All that over 55. And so from here, we look at 12. We know 12 can be broken down as 4 times 3. Oops, let me try to write that again. And 55, of course, is 11 times 5. And notice that 11 and 5 have nothing to do with 4 and 3. Or if I wanted to put this another way, 2 times 2 times 3. So we do not have any like factors here. So this is the simplest form of our answer for this particular problem. So it'll be 12a divided by 55. Or you could express this as 12 over 55a, where you keep a right here on the side. Either one of those ways of expressing the answer is correct. Okay, so either one of these ways. All right, so let's move on to our 5th example. Sorry, I meant to say the 6th example. So let's start with the 6th one. Okay, so in this example, notice that we have 4 terms and 2 of the terms are like terms with W, and we have 2 terms that have like terms with a y. So in this case, what we want to do is we want to group all like terms together. Okay. So here we have 7/9y, and this -5y we can put together with it. And we're allowed to switch the places of these because we know that addition and subtraction is what we call commutative. Okay. And that's just a fancy way of saying that we know that 2 plus 3 is 5, just like 3 plus 2 is 5. Okay. And if we're talking about subtraction, we know that 2 minus 3 is a -1, just like -3 plus 2 is a -1. So the ability for us to be able to switch the place of these numbers but still come out with the same result lets us know that these operations that we're doing, addition and subtraction in this case, the formal word for that is commutative. Okay, so if you ever see that in a math book, that is what that means when they say that a particular operation is commutative. So we have these two terms that are going to be like terms, and then we have these two terms that are like terms. And so we're going to write those together. Okay. So now that we have these two terms together, we can kind of look at these as if they're in their own little groups, and we can combine them. If you remember here, we could rewrite these first two terms as 7y/9 minus 5y/9. And second two as 2w/3 minus 4w/3. And then from here, since we have like denominators for these two fractions here, I can just write it as one term plus do the same thing for the other two. From here, we have 7 yams minus 5 yams, or 7 yams take away 5 yams. That will give us 2 yams left. Plus, I have 2 watermelons, but I take away 4. Of course, if I only have 2, but I also want 4, that means I'm short or minus 2 of those watermelons. And then I divide by 3. So at this point, we're pretty much done. It's just the only thing that we want to do here is kind of clean this part up. We know that anytime we have a number plus a negative number, and if I write it like this is the same thing as subtraction. Okay, so this is actually the definition of what subtraction is. So because of that, we don't want to leave this as as this plus a negative number here. We want to go ahead and just rewrite that as 2y/9 minus 2w/3. And we could just leave that answer that way, because all terms with y go together here. All terms with w go together here. Okay. And so at this point, there really is no need to combine them together. If you are in a course or you're taking a class where the instructor wants you to be able to combine these into one term, I'm going to go ahead and go into that. But if you don't need to do that, if you know that, hey, I don't have to do that right now, then you can go ahead and skip this part of what I'm about to say and move on to the next example. Okay. So for those of you that actually have to rewrite this in one term here, notice that we have 9 and 3. And what we want to do now is figure out what is going to be the least common denominator in between 9 and 3. Well, if we look at 3 and 9, of course, 3 is a prime number, and 9 is just 3 times 3. So we only have 3's as a distinct prime number, and the largest group of it is that. So what it's going to be end up being is that the least common denominator is going to be 9. Okay. So what that means for us here is that we have to change the second term to being in terms of 9. And to do that, we know that 3 times 3 is 9. So that means that the numerator has to be that as well. So here this would be a 2y over 9 minus 6w over 9. And now that we have like terms, we can go ahead and combine the numerators together. And that would be 2y minus 6w, all that over 9. Okay. And so here, this would be your final answer if you need to express things as one single term. Okay. Notice here, and I'll go ahead and outline this, that if you didn't have to do that, then what we had here, 2y divided by 9 minus 2w divided by 3, is the same exact thing as what this is. Okay. It just depends upon how you want to express it. You could either leave it this way or you could express it this way. And it really just depends upon what the requirements are. Okay. All right. So we'll go ahead and move on to our next example. Okay. So for our next example, the thing that is different about this one is now that we have 3 terms, but this second term here looks a little funny. And it looks funny because we have this fraction being multiplied by these 2 terms here that's in these grouping symbols. Okay. So the very first thing that we're going to do is realize that anytime we have a number being written next to some expressions or an expression with grouping symbols with it, that means multiplication. And we are going to distribute multiplication over addition. So that's the very first thing that we want to do. So we're going to come here and just say this is 5b over 7. And remember how this is b over 1. Now I can multiply 5 times b to get 5b, 1 times 7 to get that, plus. And so here, remember that b is the same as b over 1. So whenever I multiply fraction with fraction, I'll multiply numerator with numerator and denominator with denominator. Okay. So this first term here, when I distribute, is going to be 2b over 3, because remember 3 times 1 is 3, plus, remember we have to do this, multiply this 2/3 times this fraction as well. That's going to be 2 over 3 times 4 over 3, which is going to be numerator and numerator multiplied, be 8, denominator with denominator multiplied, that would be 9. So this will be 8 over 9. And then we have minus 9, okay? So what we have now is an expression that had 3 terms, but now since we had to distribute at 2/3, now it's 4 terms, okay? So at this point, we're looking and we see that we have a fraction with 7, a fraction with 3, a fraction with 9, and of course we have this 9 by itself, which is the same as having a fraction with 1. And what we want to know now is what is going to be the least common denominator amongst our 3, our 9, and our 7, okay? And again, we don't really include the 1 in this because 1 kind of goes with everything, okay? So what we do is we take our 3, our 7, and our 9, and we write out what's called the unique prime factorization. Since 3 and 7 are prime numbers, all we have to do is just rewrite the numbers themselves. For 9, we know 9 can be broken down as 3 times 3. And of course, 3 is a prime number. So here we look at what are all of our distinct prime numbers that we've written here. And we just have 3s and we have 7s. So we need to pick the row with the largest group of 3s and circle that group. And in this case, it's going to be this. And we need to pick the row with the largest number of 7s and circle that group. And since we just have 1 7, we circle that. Everything that we circle, we multiply. Okay. And notice that essentially what we've done is we said we need to multiply 7 times 9. So 7 times 9, that is going to be 63. And that is going to be our LCD for this particular problem. So now that we know what our LCD is, now we need to basically take all 4 of these terms and rewrite them as equivalent fractions where all of them have 63 as its denominator. Okay. So here I want to say 5b over 7 times something over something plus 2b over 3 times something over something plus 8 over 9 times something over something minus 9 over 1 times something over something. And remember, the numbers that we're going to put here are going to force our denominator to be this number 63 here, okay? So when we look at this, we say 7 times what is 63? Well, we know 7 times 9 is 63, okay? So here, we're going to have 9, and since that's 9, that has to be a 9, okay? I'm going to rewrite this because this is actually going to help us be able to figure out what we need to have for those other fractions. So we know that 7 times 9 is going to be the same as 7 times 3 times 3, which is 63 here. Okay, I'll just get rid of that. So here what we said is 7 times what gives us 63? Well, it's what remains here. 3 times 3, which is 9. Okay. So next what we're going to do is say 3 times what is going to give me 63. So if I look at this, 3 times what? Well, what's left? A 7 and a 3. 7 times 3 is 21. So here we'll have 21, 21. And of course, whenever we multiply these together here, I'll go ahead and start doing it here. We'll have 63 in the denominator here, and this will be 5b times 9, which is 45b. For this second term, 3 times 21 is 63. So we have 2b times 21, which is 42b. And so now we're trying to work on that for the third term. So now we ask ourselves, and I'll rewrite this again. This is 7 times 3 times 3. And so 9 times what gives us 63? Well, we know 9 times 7 gives us 63 because these two numbers here, 3 times 3 gives us 9. And we see that we have 7 left. So that means 7 is going to be in the denominator and in the numerator there. And so here, 9 times 7 is 63. 8 times 7 is 56. And then for our last one here, we know that 1 times 63 will be 63. So here we would have a 63 here, which means we need to have a 63 here, okay? And this is looking a little ugly, and I'm actually going to work this a different way because we don't necessarily have to work it like this, but I was trying to do it to keep everything together here. So we would need to do 63 times 9, and 3 times 9 is 27, carry the 2. 9 times 6 is 54, plus 2 is 56. Okay, so we could do that this way. So now that we have all this in place, we have all our denominators being the same. And now what I can do is just add them accordingly, okay? So here I'll have a denominator of 63, and notice that 45b and 42b are like terms. So these two terms are going to go together, plus these two are just numbers. So we are just going to put those two together because they are like terms, okay? And so now we say 45 bushels plus 42 bushels will end up giving us 87 bushels plus, and now we have 56 minus 567, which is the same as saying 567 minus 56, but whatever our answer is, it'll end up being negative. So we know 7 minus 6 is 1, 6 minus 5 is 1, 5 minus 0 is 5. And of course, since this is the bigger number, we know that this is going to be a minus 511. And all of that gets divided by 63. Okay. And so from there, I'll go ahead and erase this. So from there, we will have 87b minus 511, because remember, plus a negative number is the same thing as subtraction. I have all of that over 63. And this is one way to write this particular answer. So note again, this is one way that we could actually do this problem. The other way that we can do it is at this particular point, and I'll change colors here just to kind of tell you what I'm talking about. At this point, we could kind of deal with this part on its own and deal with this part on its own. And if we do it that way, it turns out to be a little bit more simple, but what we end up getting is something that looks like two different terms instead of one. And what it essentially will end up looking like is something like this. But we'll have the simplified version of this. Because one of the things that we'll see is that 87 and 63 both have a common factor of 3 in it, so we could factor that out. And we will also see here that 511 and 63 have a common factor of 7. And so we could factor that out as well. And when we do that, what we'll find out is that this answer here will also look like 29 over 21b minus 73 over 9. Okay. And so if you're watching this and you want to see how that actually turns out being that, just write this down, and then I'm going to erase all of this, and we're going to do this problem again, doing it the way I was showing you here, where we deal with these two groups of terms separately, and you'll see how it'll turn into this particular answer here. But this answer is the same as this one. Okay. If you're fine with this form of the answer and you're ready to move on, you can go ahead and skip the rest of what I'm about to do here and go to the next example. All right, so I've erased what we've done earlier here, and now what we're going to do is work this again. So first step will still be the same. This will be 5b over 7 plus, and we'll distribute, and that will be 2b over 3 plus 2 times 4 is 8, 3 times 3 is 9, minus 9 here. And so since these first two terms are like terms, we'll look at these in a group. And since these are just numbers, we'll look at these in a group. Okay. So here, since both of these are like terms, what we need is to have both of these terms have the same denominator. Okay. And if we look at 7 and 3, the least common multiple or least common denominator in between them is 21. We can just multiply them together. And we do that whenever we have prime numbers. So here we know that 5b equals 7 is going to be the same as what over 21? Well, again, since we know that 7 times 3 is 21, we got to have a 3 in the denominator, 3 in the numerator. And so that'll end up being 15b there. So this 5b over 7 is going to be the same as 15b over 21. If we do the same thing for 2b over 3, we know that 3 times 7 gives us 21. So we got to have a 7 in the numerator here. And 2b times 7 is 14b. So we do it like that. So that is for these two. Now, 8 over 9 and minus 9, which is the same as 9 over 1. We know that the common denominator between 9 and 1 is just going to be 9. So this first term will remain the same, but this second term, 9 over 1, is the same as what over 9? Well, we know that 9 times 1 is 9. So what that would mean for us is that we would be multiplying the denominator by 9. So that means I'll have to multiply the numerator by 9. And of course, 9 times 9 is 81. So here, and of course that makes sense because 81 divided by 9 is itself 9, right? We look at that in our group. So if we combine these first two terms together, and we know that we can do that because both of them is just a number times b. So 15 bowls plus 14 bowls will give us 29 bowls, okay? And remember that we can do that because here we know since we have like denominator, we can put that all over 21. This is 15b plus 14b. And here for the second term, all this will be over 9. This will be 8 minus 81. Combine 15 bowls plus 14 bowls is 29 bowls over 21 plus 8 minus 81, that's going to be a minus 73, and then all that over 9, okay? And so remember when I told you to write this earlier, I told you that we were going to come up with this result here. And we'll go ahead and clean this up to make it look like subtraction. And here, to get it back to that answer that we had before, notice that the least common denominator in between 21 and 9 is going to be 63, okay? Because remember, 21 breaks down to 7 times 3. 9 breaks down to 3 times 3. I have 3s and 7s that are my distinct prime numbers. And the group with the most amount of 3s, I circle. The group with the most amount of 7s, I circle. And everything that I circled, if I multiply it, I'm going to end up with 63. So that's how I know that. So what this means for us here is that I can multiply this first term by 3 over 3, since I know that 3 times 21 gives me 63. And I can multiply this second fraction by 7 over 7, since I know that 9 times 7 gives me 63. And if I do that, then 29 times 3, that gives me 87 over 63 minus 73 times 7, that gives me 511 all over 63. And then you see that I can combine this into one term. Okay. So this is how what we got the first time will actually end up equaling what we worked to get the second time. Okay. All right, so we'll go ahead and move on, and we have 2 more examples to do. Okay, so for our next to last example here, we see that we have, what is it, 1, 2, 3, 4, 5 terms now. Some of these terms have y in it. Some of these terms have w in it. Some of these terms are just a number. So the first thing that we want to do is try to order these to where we have all things that have like terms together. Okay, so here I can have a minus 6.8 w. So this is a like term. This is a like term. And then we'll identify this minus y and this 8.24y as like terms. And then we'll identify this one as its own term. So we'll have minus 6.8w plus 0.69w. Okay. Then after that, here I have a minus y plus 8.24y, but since I don't want to mess up my sign here, I'm going to write the 8.24 first and then do minus y. And then after that, the last term I have is a minus 2.9. So we're here, and notice that these 2 terms go together. These 2 terms go together, and this one is by itself. Okay. Now, if we think about these first 2 terms here, you can think of this as saying we have negative 6.8 watermelons plus 0.69 watermelons. Okay. Another way that we can think about this, and I'll write it here to the side, is we're paid 0.69 of a watermelon, but then someone takes away 6.8 of the watermelons from us. Okay. Either way, we know that this result is going to end up being negative here because of the fact that just magnitude-wise, 6.8 is going to be more than 0.69. Okay. So what I'm going to suggest that we do here is we factor out this w. So we can just say minus 6.8 plus 6.9 and write it like that. And again, it's the same thing that we would do if we were just to go ahead and combine these together. Because how we would do that is we would essentially say, what is 6.80 minus 0.69? And then whatever number that is, since 6.8 is larger than 0.69, we would make that negative. We're doing the same exact thing here. We're just writing it in a different way. So if we do this, of course, since in the last column here to the right, since that's a 0, we're going to borrow 10 from this column. So that's going to be 7 here. This is going to turn to a 10. 10 minus 9 is 1. 7 minus 6 is 1. And here 6 minus 0 is 6. So we know for this term here, once we're done, we're going to have a minus 6.11w once everything is done. Okay. And so I'm just writing it so that you'll have it. We're going to fill in everything else now. So for the second group, this is like having $8.24 minus $1. Of course, if you had $8.24 in your pocket and you had to pay someone $1, what you would have left is $7.24. Okay. So here, if this is yams, since it's y, 8.24 yams minus 1 yam gives us 7.24 yams. And then we just do the minus 2.9 here at the end because it has nothing else to combine with. And so we've taken care of that now. So we have a minus 6.11w that comes from this first term, plus there's nothing else left to do for the second term, minus nothing else left to do for the third term. And this is your final answer right here. Okay. So we had 5 terms, and what we did is we condensed it down to 3 terms, where we had everything in terms of W together, everything in terms of Y together, and everything that just has numbers together. Okay. All right, so let's work on our last example here. So for our last example, we see we have a combination of 4 terms where 2 of the terms are like terms of X, 2 of the terms are like terms of Y, and we want to combine these together to just be 2 terms, one with a term with X, one with a term in Y. So the first thing that we want to do here is everything that is like terms we want to identify. So everything in terms of X we have, everything in terms of Y we have. And we want to group them together so that we have them next to each other. So this will be 7x over 9. And remember how we said that x could be written as x over 1, multiply numerator with numerator, denominator with denominator. Okay, minus, we have 8x over 3 for the same reasons here. And that will get put into a group together. And then we have 8y here minus 1/5 y. Or we could write this as just y over 5. Okay. So now that we have that, for this first group, notice that we have to find the least common denominator in between 9 and 3. And if you remember before, we know that the least common denominator in between 9 and 3 is just 9. So for this first term, we don't have to do anything because it already has a denominator of 9. But for this second term, we're going to have to multiply this by 3 in the denominator here so that we can get the 9 that we have there. But that means that I'm going to have to do the same thing to the numerator. Okay. And so in the next step, we'll go ahead and simplify that to where this second term will be, will have a 9 in the denominator as well. For the second term, notice that this, or second 2 terms rather, this 8y can be written as 8y divided by 1. And so we know that the least common denominator between 1 and 5 is just 5. So if we do that, we know that this last term here, the minus y over 5, that could stay the same. But here, this 8y over 1 is going to have to be multiplied times something to get this 5 in the denominator here. And since we know that 1 times 5 is 5, that means we're going to have the 5 in the numerator there as well. So now that we want to simplify things, we know that 8x times 3 is 24x, and 3 times 3 is 9. We know that for the second term here, well, second 2 terms, this first one, 8y times 5, that is 40y divided by 5 minus y over 5. And so now that we have that together, we know that for these first 2 terms, since they have like denominators, we can now combine them together. Okay. And for the second 2 terms, have like denominators, so we can combine them together. Okay. And remember here that this minus y here is the same thing as a minus 1y. We just don't write the 1 usually because it's understood, but I'll write it here for clarity. So once we're here, we have 7 apples minus 24 apples. Okay. And so to figure that out, if you can't, do that in your head, you can just say 24 minus 7. Of course, do that and you'll end up getting 17 there. And since 24 is larger than 7, then we know that we just make this negative here. So this would be a negative 17x over 9 plus 40 yams minus 1 yam gives us a positive 39 yams, all that over 5. Okay. And so from here, again, our final answer, if we want to keep it in this form, would be a minus 17x over 9 plus 39y over 5. Okay. This could also be written as 39 over 5y minus 17 over 9x. Okay. It can also be written that way. And again, if you were asked to write this as one quotient here, then what we would have to do is find out what is going to be the least common denominator in between 5 and 9. In that case, it would be 45. And I'm going to leave it for you to try to figure out what this is going to be here. Okay. Essentially, you would need to find out what you need to multiply by 5 here in the denominator and numerator to get 45 in the denominator. Well, let me say that again. You need to multiply a fraction here such that in the denominator, you're going to get 45, and that fraction would have to be the same number on top and on bottom. You'll have to do the same thing here. You'll have to have some fraction number divided by the same number. And this number here, when you multiply it times 9, would have to give you 45. And once you combine that together there, that will give you what you should have as an equivalent answer, but everything being in one term. Okay. All right. So with that being said, just to kind of circle back, this is your final answer here. And you see how we put it all together. And this is our final example for this particular video. So I know we've been at this for a while, but I wanted to make sure that we had plenty of examples so that we could see all the various twists and turns that we could possibly have with problems like these. I hope this helped. Take care.